Hello, welcome to Science Talk. I am your host, Jim Massa. I want to discuss with you new concerns the scientists have raised about how global warming can actually bring on even further heating, more heat. Now, in a previous video segment I discussed how we have not seen on such a large global scale, over 98% of the Earth's surface, and synchronously done, of such warming on the scale that we have seen for the last 150, 200 years. Basically, human activity has caused this worldwide, everything's synced up tightly together. The era that come the closest was happened in the early Eocene, which is about 56 million years ago. Now, I did discuss that in a prior video segment of what happened in the Eocene, so you may want to check that out. And there was some, of course, it's very difficult to ascertain precisely, without still ending up with a large error factor. But the heating there, which was as much as 9 degrees hotter than today, Celsius hotter, 9C hotter, was that it didn't happen in such a short time period. I mean, 150 to 200 years is not even a blink. But here, you have over, several million years of this heating. So even then, when the whole planet was heating up, this still wasn't synchronous. It still happened over a very long time period, certainly not 1 to 2 centuries. So basically what they are warning us, these climate scientists, is that as the CO2 levels continue to increase, global warming would accelerate. Oops. In other words, look at Venus. So, they looked at they did computer simulation. I'm going to discuss that here. But this 56 million years ago, this shift then, the early Eocene, atmospheric CO2 levels rose at least 1,000 parts per million, and perhaps went higher. For most of human history, CO2 levels have been around 285 parts per million. Now past 400. About 416 or so, plus or minus. At this rate, if humans keep doing business as usual, they're actually saying that the levels could hit 1,000 by the end of this century. That's 80 friggin' years away. Even if it hit 500-600, it's like, holy shit. They're talking 1,000 in 80 flippin' years. And as I said, last time this happened on such a scale was the early Eocene, 56 million years ago. Surface temperatures were, mentioned before, 9 degrees C hotter than today. Scientists continually look at that time period to draw lessons. One of the things you do in geology and climate science or paleo work, anything, is you look to the past to learn about the present situation. So what happened back in the early Eocene? Polar ice melted, not a surprise. Antarctic ocean temperatures reached 20 degrees C. Now remember, the positions of the continents weren't quite what they are now. Close, but not quite. Sea levels rose dramatically. Well, of course, if you have no land ice, only oceans. Oceans became increasingly acidic. I've discussed in other video segments how the pH of the ocean is becoming more acidic. And I've also discussed how this is affecting organisms that need calcite to form their shells, their tests. Because as the ocean becomes more acidic, their tests and shells are going to be dissolving because the solubility of calcite, calcium carbonate basically, increases with lower pH. And we're also seeing what's called the lysocline. That's the level where we go from calcite precipitates to calcite dissolved is getting shallower and shallower, endangering more and more organisms, including corals. right? And we're seeing the bleaching of corals. So we're seeing the ice melting in the polar regions. We're seeing the increase in sea surface temperatures. We're seeing the sea levels rising. The ocean is becoming more acidic. We're seeing this right now. So what happened back in the early Eocene is happening right now again. And mammals evolved to be smaller. Why? Because if it's warmer, if you're large and bulky, it's difficult to cool off. Where if you're smaller, you increase the surface area to volume ratio, you can cool off more readily. And it was so warm back then, we found crocodiles in the Arctic. So, in the scientists from the U.S. Published a research paper in the journal Science Advances. For the first time, they were able to simulate the extreme surface warmth of the early Eocene in a computer model. After decades of geological investigation, there's not much argument about the real conditions 56 million years ago. Now, they have a pretty good handle on it, of course, within statistical error bounds, and immensely high levels of CO2. In other words, it's a well-established fact. Temperatures are related to CO2 levels. Increase the CO2, temperatures go up. Decrease the CO2, temperatures go down. What is not clear is quite how the link between atmosphere and temperature in the early Eocene, how that worked out. They got a better handle on that. So this study managed to incorporate models of water vapor, cloud formation, atmospheric aerosols, and other factors that would have set up a system of feedbacks that might lead to the tropics being extremely sweltering, as well as the polar regions being quite warm. Now, water vapor, especially cloud formation, all these things, atmospheric aerosol, these are extremely difficult to model and incorporate. But with ever increasing computer sophistication, we're now able to get a handle on this and improve our climate models. There's an old joke, if you look at, say, the episodes from the Star Trek, the original series, Enterprise comes cruising to go into standard orbit around the planet, and you see this planet below, and wow, look at that, nice oceans and continents, stuff like that. Where are the clouds? And the joke was, clouds are hard to model. Geek joke, I know. But anyway, but we're getting a handle on it. And because we're getting a handle on that, we're improving our model. And like I said before, when the models are able to recreate what we already have observations for, then we know that any extrapolation into the future is going to be valid. We're able to reproduce confidently, with at least 95% confidence, if not 99%, and therefore, okay, now we can extrapolate out. So, improvements there. So, Christopher Poulsen of the University of Michigan, lead author, lead scientist, for decades, the models have underestimated these temperatures, and the community has long assumed that the problems was with the geological data, or that there was a warming mechanism that had not been recognized. Co-author Dr. Jessica Tierney of the University of Arizona said, for the first time, a climate model matches the geological evidence out of the box. In other words, we didn't have to sit there and tweak things too much. And as he goes on to say, that is without deliberate tweaks made to the model. So basically, it's greatly improved our knowledge of what happened in the early Eocene, and therefore, we have a good handle now, an improved understanding of these factors: water vapor, cloud formation, aerosols, as well. Other scientists have already predicted that what happened in the early Eocene could turn out to be a lesson for what is happening now. I agree. The finding may work into a bigger puzzle problem that is referred to as climate sensitivity. What is climate sensitivity? How so much extra carbon dioxide might lead to so much average global temperature rise. That's climate sensitivity. In other words, you throw in so much extra CO2, how does the average global temperatures respond to that? And turns out, why is so much CO2 leading to such an increase in global temperatures? So it has to be basically a non-linear aspect to all of this. So basically, as it turns out, been underestimating all this time. Researchers had assumed that the one would be in step with the other. But the latest finding raises the possibility that warming might indeed accelerate as CO2 concentrations increase. So far, the world's warmed by around 1 degree C in the last century. It's more like 1.3. Planet perhaps on track to pass 3 C by 2100. That's now turning out to be an underestimation. More recent studies have warned that this could be a serious underestimate. The lessons of the early Eocene that played out over hundreds of thousands of years, not a couple of centuries, is that the question of climate sensitivity has yet to be settled. So further research required. So Dr. Zhang Zhu of the University of Michigan, who was the lead author and the main principal investigator, we were surprised that the climate sensitivity increased as much as it did with increasing carbon dioxide levels. It is a scary finding because it indicates that the temperature response to an increase in CO2 in the future might be larger than the response to the same increase in CO2 now. This is not good news. Like I said before, scientists have always assumed a linear increase in temperatures, a linear increase in ice melt. And now we're finding out that the temperature is not necessarily going to increase linearly. Ice melt is not going to necessarily increase linearly. It's going to be exponential. It kind of ties in here. They're basically saying, CO2 levels are going to bring on a really rapid exponential temperature increase. That is, in essence, what they're warning us of. So does 3 degrees C by 2100 might be a low ball. So this is concerning news. But, as I said before, as our models improve, so do our estimations. Thank you for your time. Hello, folks. This is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.